Okay, so we're just going to look at 5 things of prior knowledge that we need to be able to be successful for binomial distribution. The first thing that we need to look at is calculating the probability of an event happening. This can be shown in quite a few different ways, but we're just going to look at a couple of examples here. So in this one, 20 employees work in an office in one of 2 teams. So one employee from team A is selected at random and one employee from team B is selected at random. And team A, as you can see in the table, has 8 employees and team B has 12. So Nabir is in team A and Jenny is in team B. So the first question, write down the probability that Nabir is selected. So Nabir is one person out of a team of 8 people. So the probability of him being selected is 1/8. And the probability of Jenny being selected, so she's in team B and she is one person out of the 12 employees in team B. So 1/12. And then who is more likely to be selected, Nabir or Jenny, and give a reason for your answer. So here we need to work out and compare fractions of 1/8 and 1/12. So when we're comparing fractions, we have to make the common denominator. So the lowest common multiple of 8 and 12 is 24. So we've had to multiply 8 by 3 to get 24. So we multiply the numerator by 3 as well. So 1 times 3 gives us 3. So Nabir's probability is 3/24. And then to get 12 to 24, we've had to multiply by 2. So we multiply the 1 by 2 as well. And that gives us 2. So Jenny's probability is 2/24. So 3/24 is bigger than 2/24. So Nabir is more likely to be selected. Okay, so that's one example. The second example I want to look at for calculating the probability of an event is we're looking at a bias coin and it's twice as likely to land on heads as tails. So that means for every 2 heads, there's 1 tails, which means in total, there's 3 parts altogether. So the probability of landing in heads is 2 in every 3. So 2 out of 3, so 2 over 3. And the probability of landing on tails is 1 in every 3, so 1/3. Okay, so that's the first part. The second part we need to be good at is calculating the probability of an event not happening. So to do this, we need to know that all probabilities have to total 1. And then we're going to take away the probability of the event happening away from 1 to find out the probability of the event not happening. So what's the probability of the bead not being blue? So we're going to do 1, subtract the probability that it is blue, which is 4/8. So 1 take away 4/8 leaves us with 4/8, and that can be cancelled down to 1/2. The probability that the bead is not red, so 1 take away the probability that it is red, is 2/8, which leaves us with 6/8, which we can then simplify to 3/4. Probability that it's not green is 1 take away the probability that it is green, and there's 1 green bead out of 8. So 1 take away 1/8 leaves us with 7/8, and that one can't be simplified. And then the probability that the bead is not yellow is 1 subtract the probability that it is yellow, which again is 1/8. So our answer here is 7/8. So that's part 2. The third thing that we need to be good at and understanding is using tree diagrams. So Felicity is going to play 1 game of chess and 1 game of drafts. So we're going to have the first set of branches is for the chess game, and the second set is for the drafts game. And then the probability that she'll win the game is 0.8. So we've got that she's going to either win or she's going to lose. So this is 0.8. And then the probability that she's going to lose is 0.2. And then with the drafts game, again, she's either going to win or lose. And then she's either going to win or lose. And it says here the probability that she's going to win the game is 0.6. So the probability that she's going to lose is 0.4. So win 0.6 and lose 0.4. So we've then got here, work out the probability that she'll win exactly one of the games. So win 1, so she can't win 2. So she's either going to win and then lose. So we've got 0.8 multiplied by 0.4, or we've got lose and then win, which is 0.2 multiplied by 0.6. So if we multiply this, we get 0.32. And we multiply across here and we're going to get 0.12. And then because it's this option or this option, we're going to add them together. And then that gives us a total of 0.44. Okay, so the fourth thing we're going to look at is binomial expansion. So there's just a couple of questions here. So we're going to expand this bracket. So we have to multiply x by both the terms in here. So x times x gives us x squared. X times y gives us xy. Y times x gives us xy again. And y times y gives us y squared. And then when we simplify that together, we're going to get x squared plus 2xy plus y squared. And then if we had to expand 3 brackets, we've already done the first part. If you can see, the first part is the same as question 1. So we're going to put the last bracket in front of our answer to part 1. So x squared plus 2xy plus y squared. And then we're going to expand. So we're going to times x by this. So we're going to get x cubed, x times 2xy. Now it's important that the indice is with the correct letter. So this is x squared y. And then x times y squared is going to give us x y squared. Now we're going to multiply everything through by y. So now we've got x squared y. And then now we're going to have 2xy squared. So 2xy squared. And then y times y squared is going to give us y cubed. And then we're going to collect these together. And we're going to get x cubed plus, and then we've got 2x squared y and 1x squared y. So that's going to give us 3x squared y. Then we're going to get xy squared and 2xy squared gives us 3xy squared. And then we've just got the y cubed on the end there. And then the last thing that we need to take a look at is just substituting into formula. So we've just got a really basic one here. So we've got 3 lots of 2.2 because that was the value of C, and then we're adding 0.5 onto that. So 3 times 2.2 is 6.6, and then we're going to add 0.5, and that's going to give us 7.1. And then we've just got one more example of substitution, and that is just when there's negatives in here. So we just need to be careful with this. So if A is 4, and we're going to multiply that by B, which is 9, and then we're going to add 24, and then we're going to divide the whole thing through by 2 times negative 5. So if we simplify that, we're going to get 36 plus 24 divided by negative 10, which is going to give us 60 divided by negative 10. So the answer is negative 6. And they're the 5 main things that we need to be successful at binomial distribution. So I just have some questions here. So if you have a go at these, and then in the next video, I will go through the answers.